Limits. The limit, so this right here is read as the limit of f of x as x approaches c equals n. Okay, that is how that's read. The limit of the function as x goes to a number equals n. Limits are typically used in Calc 1. This is just a teensy little introduction to limits. And the limit is what the function is headed to as it goes to that. Typically, it's used for asymptotes where it doesn't exist, holes, things like that. What would the value be if it could reach that point? So using a table. So using a table, you're just going to use your calculator. I'm not going to do this one using a table. I need to edit this lingo a little bit. What you do when you have a function that's domain is all real numbers. So the domain of this function of 5x squared, that's a quadratic function, is all real numbers. When the domain is all real numbers, you just take the c value that you have and plug it in for x. So 5 times 3 squared is 5 times 9, which is 45. Boom. Done. That's most of it, truly. When it does not exist, right here. So if we plug 2 in, we get a 0 on the denominator. So this function has a domain of x cannot equal 2. Well, since that's what we're trying to figure out, we're going to simplify this function when it's possible to simplify. You can't always simplify, but when it's possible to simplify. This numerator is x squared minus 4 is the difference of squares. So we have x plus 2, x minus 2 over x minus 2. Since those cancel out, we get x plus 2. Now, it still does not exist at 2, even though those cancel, because this is our overall function. But we can plug in this into the simplified form to find out what it would be if we were in an alternate reality and it did exist. So 2 plus 2, your limit is 4. Your function is getting closer and closer to 4 as it goes to 2, is what's happening there. You can look at that on a table of values, and I will show you a table in just a second. This one, the domain of that function is all real numbers. It's linear. You can plug in anything you want and get something out. So 2 plus 2 again is 4. Did I lie about this being simple? Not yet. Oh, you're welcome. Got you.
Okay, real quick.
Yeah.
What is the little symbol you keep drawing for all real numbers?
Oh, it's just a double barred R. You'll see it in college math. They use different symbols to denote different sets of numbers, like natural numbers, rational numbers, things like that. And one just means real numbers. All it translates to is negative infinity to infinity. It's the same thing. All right, this one's a little different. The sine of x over x. You can't simplify this one like we did A. You can't plug in that 0 because you get 0 on your denominator. So this one has a domain where x cannot equal 0. So we are going to use a table. Because we have sine, we have to be in radians mode. But we're going to look at a table of values. So to look at a table of values, you first have to plug it into your calculator. So you have the sine of x divided by x. So there's my table. Oops, there's my graph. Just kidding. That is what that graph looks like. Here is my table of values. And I want to know what your function is getting closer to as it gets closer and closer to 0. So to look, that 8.45 on both sides, it's going the same direction. I just want to see what it's getting closer to. So I'm going to adjust this value. I'm going to go to my table set, and all this information is in your note in the key on the line, online. So second window, we're going to adjust our table. I want my table to start at 0 because that's what I want it to get closer to. And I want it to, instead of going up from 0 to 1, I want to see what's happening as we zoom in a little bit. So I want it to go up by 0.1. Second window up at table set. And then I'm gonna look at my table. And I wanna look at it from both directions. So this one, 0.9983, 0.9983. You can adjust that even further. Want it to start at 0 and have it go up by 0.01 to see what it's getting closer and closer to. And hopefully you can see, look at 0.01, it's so close that it says it's 1. So your limit there is gonna be 1. I'm gonna reset my calculator so my table is back to normal. Questions on using the table?
How do you reset again? Second.
Second plus 712. All right.
And when we do that, what would we use the second class?
Mhm.
What other thing do you use that?
Anytime you just want to reset your calculator, it sets it out back to function
Oh, we don't-
mode, back
we
to
don't-
radian
We
mode,
do it on effective.
clears your list, clears your matrices,
Yeah,
things like that. Clears it all out. All right. By graphing. So this is a piecewise function, but the equation editor doesn't let me do it like that. So f of x, this is what my function looks like for real. We have 3x minus 2, and x when x is not equal to 2, and 3 when x is equal to 2. So we're going to graph this equation. Three x minus 2 when it's not equal to 2, bless you. I'm going to start by graphing this linear equation using my y-intercept, which is -2, and then my slope, just remembering to skip the point where it would be at x equals 2. So I'm going to go up 3 over 1, because that's my slope. Up 3 over 1. So it doesn't exist here, so that's an open circle. Up 3 over 1. And this is what my graph looks like for that first part. Not perfect. And it's 3 when x is equal to 2. So we have that point there that's just below it. Questions on graphing that piecewise equation? So now we want to look at the limit. So whenever you're looking at a graph, you're going to have to look at the limit from both directions. Get my headphone cord to leave me alone. So we're going to look at the limit of f of x as x goes to 2, but we're going to look at it from the left. That negative up front means from the left. Or that negative like in the exponent. Thank you. You're the best ever. Sorry, I get up for double attached. Thank you so much.
Expect that to be on.
All right, so from the left, our function is getting closer and closer to that y value there, which is 4. So then we're going to look from the right. So the limit as x goes to 2 from the right is what the positive means of this function. So from the right, as we get closer and closer to 2 from the right, again, we are looking at 4. So because this approaches the same value, it's one to know what your function is approaching, not necessarily what it actually is. So because we are approaching the same value from both directions, then our limit exists, and that's the limit of the function overall. Questions?
When it's like, when it's talking about from the left to the right,
Mm-hmm.
is it just like the first point?
Yes, so it's where your function is going at the x value. So we're looking at this value from this direction. So if we get closer and closer here, our function is getting closer and closer to y equals 4. If we go from this direction, our function is getting closer and closer to also y equals 4. So when you have asymptotes, especially asymptotes that go in opposite directions, this is what you'll use, and we'll look at one of those in just a second. You can see where it's going, if it's going to infinity. That's kind of more what this is used for. Or if your function stops here and then picks up on this side and goes to up here, then your function wouldn't exist because it's approaching two different places there. So your limit doesn't exist. We'll look at it. It'll make more sense once we put it all together. The next one. The limit of f of x, limit as x goes to 0 of this function. Here is our piecewise function again. We have x when x is less than or equal to 0. And we have 1 when x is greater than 0. So I'm going to graph this function. Less than or equal to 0, my y-intercept is 0. My function is x, so it's just -1, -1, -2, -2, -3, -3, right? When x is greater than 0, it's at 1. So we have a hole there at 1, and then we're going to be 1 the whole way across. So that's the graph of that function. So now we're going to look at the limit from the left. So the limit of the function as x goes to 0 from the left. So as we get closer and closer to our y-axis, that's x equals 0, our function actually touches 0 at this point. So that limit is 0.
Okay, so can you do that again? I'd like to understand the difference in the left.
From the left, this is left, this is right, right? So from the left, we're looking at where our function is headed as it gets to 0 from the left. To 0. Stops at 0. It actually has that point at 0, so it's 0.
Okay, so what do you do when there are two that are
Now that's what I'm fixing to show you. So the limit as x goes to 0 from the right of your function. From the right, we're getting closer and closer to 1. If this were the function the whole time, then it would be 1, right? So because these are different values, 0 is not equal to 1. Then the limit of your function overall as x equals 0 does not exist. If it's headed towards different values, your overall limit does not exist. It has to be headed towards the same value in order for your limit to exist. Questions? All right, with the next one. If we plug into, I'm just going to save you a little work. You get 0 on your denominator and you get something that's undefined. So what I'm going to do, I'm going to use my table and I'm going to type this function into y equals using parentheses around the numerator and around the denominator. So I have x cubed minus 2x squared plus 4x minus 8 divided by x to the 4th minus 2x cubed plus x minus 2. And then I want to look at my table. I want to look at what's happening as x gets closer and closer to 2. So I'm just going to look at my table here without adjusting anything. And at 2, from the left, I'm at 2.5. And from the right, I'm at 0.46. Well, it can still get closer and closer. So I just need to zoom in and verify what's happening here. So now I'm going to go to my table set. I want my table to start at where I'm looking at. So I want it to start at 2. And I want it, because the difference was so drastic, I'm going to have it go up by 0.001 and see what happens. If you look at that, you can see that it's getting closer to the same spot. Not quite the same, but close to the same. So what I'm going to do is I'm going to adjust it again. I want my table to start at 2, and I'm going to say 0.0001 and see if that helps me. And those are really, really close together. This one rounds to that one. So I'm going to say that my limit is at that 0.889 or 0.8889 or however you want to round it. So my limit of this function, because it's going to the same spot on both sides, is going to be that value, about 0.9, 0.889. Questions? All right. Now, a little more. Find the limit of a constant. The limit of a constant is just the constant itself. When there's not a variable, if you plug in 3, it doesn't change anything. Your limit is 5. When you have a limit of the equation like this, you just plug that 3 in for x, and so your limit is 3. C is like A, there's no variable, so our limit is just the function. The domain of this function, if you were to graph it, is all real numbers. You can plug anything in, it doesn't change it. No matter where you are on the graph in terms of x, your y is always that number. Here, the limit of 1/2, the limit as x goes to 1/2 of x, just plug in that 1/2 for x, and that's your answer. Questions on those? Huh? Haha, no. Good try that. The limit of the sum is the sum of the limits. You can split it up and find the limit of x and the limit of 4, or you can just plug in your -3. So you have -3 plus 4, which is 1. I don't see the point in splitting it up. There is a point in your math career when that will become helpful, but right now, this is not helpful. Plug in your 4. 6 minus 4, my limit is 2. Almost done.
What's gonna be on our test on this?
Remind me in a second and I'll tell you. Limit as x goes to 5, so I'm just plugging this in. The limit of the product is the product of the limits. So you can say the limit of this part times the limit of that part, or you can just plug it in and you get -20. Because that's a -4. Oh, +5, sorry. Well, the next one, we're plugging in that -2, so I have 3 times -2 minus 5. 3 times -2 is -6, minus 5 is -11. And then here I have 5 times 2 squared. 2 squared is 4. 5 times 4 is 20 again. I know. It's just basic math. Most of the time. There are a couple of little things in there that's different, but most of it's just basic math. For now, when you get to calculus, it is not basic math again anymore. Because it adds in derivatives and integrals. Because it's useful. It's useful, that's why. So here I'm plugging this one in. I have -4 times 2 cubed. 2 cubed is 8. -4 times 8 is -30. And then this one, it's longer. I'm just going to plug it into my calculator. I have 5 times 2 to the 4th minus 6 times 2 to the 3rd plus 3 times 2 squared. Oopsies. What I get? Ah!
Plug into all those buttons.
Yep, plugging into in all of those spots, and I get 50. Yep, 50. We're raising these limits to a power. Remember that in this case, you can write radicals as power over root. So this is 5x squared plus 8 to the 1/2. This one, the third got cut off. This is to the 4/3 power. So right here, I'm just plugging that in. So I have 3 times 1 minus 5 to the 4th power. And you can just type that straight into your calculator. 3 minus 5 to the 4th, and you get 16. This one, though, we have the square root, so I do want it to be in radical form here. So 5 square root of 5 times 0 squared plus 8 is equal to the square root of 8, which can be simplified because 8 has a perfect square factor of 4. 4 times 2 is 8. The square root of 4 is 2, so the answer to this one is 2 root 2. And then that last one you can just plug into your calculator. You're plugging in -1. So you have 5 to the times -1 to the third minus -1 plus 3, and this is all to the 4/3 power, and you just get +1. This one I plug in 1. Type it in your calculator. 5 times 1 cubed minus 1 plus 2. Make sure when you type it in, you put parentheses around your numerator and your denominator. And you get, I'm going to make that a fraction, 6/7. B, if you plug 3 in here, you get 0 on the denominator. So I'm going to factor this guy. Factors of 6 that give me -1 are -3 and +2. The denominator is difference of squares, so that's x plus 3 times x minus 3. Those x minus 3's cancel. Oof. So now I can plug 3 into this equation to get my limit. Remember, your function still does not exist there, but this is what it's going to be heading towards. So 3 plus 2 is 5. 3 plus 3 is 6. So if you look at it in a table, it will head towards 5, 6. Part C, this one we're going to split up a little bit. You can look at it in a table if you want to, but I just want to show you where the sum of the limits is actually helpful. This is equivalent to, I'm going to write it up here, the limit as x goes to 0 of 5x over x minus the limit as x goes to 0 of the sine of x over x. We did the sine of x over x earlier in our calculator. We looked at the table, it was 2c, and we got that this one was 1. So this -1. This one, my x's will cancel out. It still does not exist, but my limit there would be 5. 5 minus 1 is 4. Question?
Wait, that's C?
That is C, yes.
Oh, so you just broke apart.
Yeah, I just broke it apart. So that's where breaking it apart can sometimes be beneficial without having to look at your table. The last one, if you plug 2 in, you'll get 0 on your denominator. I'm going to factor this. You could also put it in your table and look at that. But I'm going to show you how to factor this. I'm going to factor by grouping. May have to add a sticky note to it. If you want to write it up higher, that's fine too. I'm just going to go ahead and add a sticky.
We could have last.
Yep, you can totally plug it in. So here I'm going to factor out the top. So I have my top part here. I can pull out an x squared. I'm left with x minus 2. The second part, I can pull out a 4, and I'm left with x minus 2. So my numerator, factored form, is x squared plus 4 times x minus 2. My denominator, my first part, I can pull out an x cubed. I'm left with x minus 2. And then the second part, I don't have to pull anything out, so it's like having a 1 times x minus 2. So my denominator is x cubed plus 1 times x minus 2. The factor that made your denominator 0 cancels out. So now you can plug 2 in. So I have 2 squared plus 4 over 2 cubed plus 1. 2 squared is 4. 4 plus 4 is 8. 2 cubed is 8. 8 plus 1 is 9. So your answer for that one is 8/9.